Hello, dear friends. So, this is our concrete civil concepts classes, and here we will discuss about the 20 important questions on steel structure, Part B. Earlier, I have uploaded and posted my Part A video, and I have covered 25 important questions, which is usually asked in your examination. So, move on to the first question of this session. The load on connection is not eccentric for as the double cover butt joint. Okay, we know in case of double cover butt joint, eccentricity of force does not exist and bending is eliminated. So it exists in case of lap joint. So option C, double cover butt joint is correct. Second question is when load coincides with the CG of rivet group, then the rivets are subjected to. Okay, so when loads coincides on the CG of the rivet group, then we know the rivets are subjected to two forces, that is forces due to axial load and forces due to movement. So in this case, this is a case of non-eccentric connection. Okay, as the load line coincides with the CG of the rivet group. So the option A, shear, is correct. So here you can see when your loads coincides with the CG of the rivet group, that is your non-eccentric connection, then the rivets are subjected to shear only. So you have to keep in mind when the loads are subjected to CG of the rivet group, and that the answer will be shear. So option A, shear, is correct. Move on to the next question. By providing sufficient edge distance, which of the following failures of riveted joint can be avoided? We know if we provide insufficient edge distance, then shear failure of plate will occur. Okay, so also we know that tearing failure of plate will also occur due to insufficient edge distance. And you know the strength of plate is less than the strength of rivet, then we have a bearing failure and splitting failure of plates also. So you have to keep in mind that shear failure of plate and tearing failure of plate is occurred due to the insufficient edge distance. So option A is correct, and we know the strength of plate is less than the strength of rivet, then bearing failure of plate or splitting failure of plate will also occur. Option A is correct in this regard. Move on to the next question. The cross section of a standard fillet is a triangle whose base angles are 45 degree and 45 degrees. So we know for a 45-degree fillet weld, throat thickness T is equal to under root 2 times size of weld. So here you can remember that two angles are 45 degree and 45 degree. Okay. So here option A is correct. Move on to the next question. Bolts are more suitable to carry axial tension. Okay. It is directly asked in your examination that bolts most suitable to carry axial tension. Okay. Now move on to the next question. That is IS 800 2007 is based on, we know IS 800 2007 is based on our limited state method of design. Okay. And in earlier we have RCC design philosophies like working stress method, limited state method, and debate load method. But we know all the members or the structures is designed only for limited state method of design. Okay. So here we have limited state method of design, limited state of collapse and serviceability. Okay. So the option C is correct. Next question is lacing bars in a steel column should be designed to resist. We know it resists transfer shear force, and that is V is equal to 2.5% of axial force in the member. Okay, so column load, that is option B is correct. And for a single lacing system on two parallel faces, the force, that is either compressive or tensile in each bar, force will be determined as V upon 2 sin theta. Okay, and for double lacing system on two parallel planes, the force in each bar will be calculated as V upon 4 sin theta. So you have to keep in mind for single lacing bar we have no F is equal to V upon 2 sin theta, and for double lacing bar we have F is equal to V upon 4 sin theta. And we know the lacing of compression members should be designed to resist a transfer shear force of 2.5% of the column load. So option B is correct. So move on to the next question. If 20 rivets are used in lacing bars, and then minimum width of lacing bar should be, as per ISQ 2007, we know the width of lacing bar depends upon the nominal rivet diameter. Okay, if we are having a 22 diameter rivet, then width of lacing bar should be 65 and likewise we have a 20 nominal rivet there, and we have a width of lacing bar 60 then 18 for, that is for width of lacing bar will be 55 and for 16 diameter we have a width of lacing bar is 50 So in this question, it has been asked that 20 rivets are used. So we have our width of lacing bar is 60 So it is your direct from the Indian Standard 800 2007. Okay. So you have to keep in mind this clause. So move on to the next question. In a gusseted base, when end of the column is machined smooth for complete bearing, the axial load is transferred to base slab. So we know if the column ends and gusset materials are not phased or not machined for complete bearing, then the fasteners are designed for total forces to be transferred. And if they are phased or machined for complete bearing, then 50% of the forces are transferred directly by the column and 50% through the fasteners. So here option C is correct. That is 50% by direct bearing and 50% through fastening. Okay. So move on to the next question. Slenderness ratio of the splices for compression members is 0, as we all know that splices used in the compression members are assumed to act as a short column with 0 slenderness ratio. Here slenderness ratio for splices are 0. Okay. Here you can see it is your act as a short column. So slenderness ratio of the splices for compression member is 0. So move on to the next question. Which of the following is a compression member? Okay, so here we know strut is a compression member used in the roof truss and bracings. Likewise, we have a boom. Okay, which is the principal compression member in crane. So here you can refer that boom is a compression member. Okay, so it is in the crane part. So boom is a compression member. Likewise, we have a strut. It is also a compression member. And the rafter here, principal rafter is a top board member in a roof truss. Okay, so column or post is a vertical compression member, okay, supporting flats girders in a building, and the tie rods are the sag rods provided at the crown of the truss in an industrial building. Okay, so tie is a engine member, and here rafter principal rafter is a top board member in a roof. So you have to remember that your boom is a compression member. Okay, so answer B is correct. Compression member is boom. Next question is the maximum slenderness ratio of a steel column, the design of which is governed by wind or seismic forces. Okay, so the answer should be 250. As we know that as per Indian Standard 800-2007, we have our table that type of member and maximum slenderness ratio. So we have three types of members, like we have a member carrying compressive loads resulting from only dead load and live load. Okay, so if we are having a member which is subjected to dead and live load, then in that case maximum slenderness ratio will be 180. Okay, but here in this question it is asked that member subjected to compressive loads resulting from wind or earthquake loads, that is seismic forces, provided the deformation of such member does not adversely affect the stress in any part of the structure. So in this case, we have a maximum slenderness ratio value is 250, and we have a next type of member is a tension member carrying tension but subjected to reversal of stresses due to wind or earthquake forces. Then in that case, option D will be correct. That is your maximum slenderness ratio will be 350. Okay, so you have to keep in mind that member subjected to compressive loading and resulting from wind or earthquake load, then the maximum slenderness ratio will be 250. Okay, so option B is correct, 250. So move on to the next question. A steel beam supporting loads from the floor slab as well as wall is termed as spandrel beam. Okay. So we know when a steel beam supporting load from the floor slab and wall is known as spandrel beam. This is directly asked in every competitive exam. So you have to keep in mind this is very important questions and 1 mark question. So spandrel beam you have to keep in mind. Move on to the next question is a grillage base is checked for bending, shear, compression, and web crippling. So we know the grillage base essentially consists of steel beams encased in concrete, and they are provided when the load on the column is very heavy. Okay, and the bearing capacity of the soil in which the concrete block is to be placed may be poor. Okay, so in that case, grillage base may be designed for bending, for shear and web crippling. So option D is correct. Grillage base is checked for bending and shear and web crippling. So you have to keep in mind the grillage base is provided when your load on the column is very heavy and the bearing capacity of the soil is poor. So option D is correct. So move on to the next question. Generally, the maximum deflection of steel beam should not exceed. Okay, so this is directly empirical question which is usually asked, and that is the deflection. Maximum deflection of steel beam should be 1 by 325 of the span. Okay, so you have to keep in mind this 1 by 325. Move on to the next question. Minimum spacing of vertical stiffeners is limited to, as we all know that the vertical stiffeners are provided at the spacing of 0.33 d to 1.5 d, where the d is the distance between the flanges, ignoring fillets. Okay, so and if the horizontal stiffeners are provided, then d is the maximum clear depth of the well. Okay, so spacing can be reduced near the supports where shear force is large compared to the center of the girder. So here option B is correct. That is D upon 3. Minimum spacing of vertical stiffener is limited to D by 3. Minimum spacing is D by 3. Okay, so move on to the next question. The economical depth of plate corresponds to minimum weight. Okay, so this is important question, one of the important questions. It is asked that is the economical depth of plate corresponds to minimum weight. Okay, don't get confused with maximum weight or minimum depth. So it is minimum weight. So move on to the next question. The range of economical spacing of truss varies from, so we know the economic spacing of the truss is the spacing that makes overall cost of truss, purlins, roof covering columns minimum. Okay, so the spacing of roof trusses can be kept as 1 by 4 of the span for up to 15 meter. We know for up to 15 meter we have a spacing of roof truss 1 by 4 of the span, and for beyond 15 to 30 meters 1 by 5 of the span the roof truss will be adopted. So the economical range of spacing truss varies from L by 3 to L by 5 in this regard. Option A is correct. Next question is the economical spacing of roof truss depends upon the, we know it is cost of purlins and cost of roof covering. We have a formula T is equal to 2P plus R. Okay, cost of purlin and cost of roof covering. So economical spacing of roof truss depends upon the cost of purlin and cost of roof. Move on to the last question of this video, that is the effective length of a steel column when both ends are bent or both ends are hinged, and effective length in that case is equal to 1L. Okay, so here when both ends of the columns are bent, so we have a case that is effective length is equal to L. So it is equivalent to L. Okay, when both ends are your fixed, then it was effective length as per your steel column is 0.65 times L. Okay, so this is important question. It is asked that is effective length when your end conditions are changed. Okay, So you have to keep in mind, and this is given in your standard 800 2007 also. So these are the important questions on steel structure part B, and I have covered in my two videos, that is part A and part B, all the most important questions for competitive exams. And do like, share, and subscribe for more videos of civil engineering. And thank you for watching this video.